if the ground is shaking at 100 times per second, how many times per second do you think we need to record it to be able to replicate that signal? Well, you might think 100 times per second because that's how quickly it's moving. Let's look at this as a simplified 100 Hertz sine wave. If we sample that 100 times per second, we're going to pick up the same point on that sine wave every time we sample. So it'll come out like a flat line. That means we need to sample the signal at least twice as fast as the signals that we're interested in recording. By that reasoning, we should be sampling at 200 samples per second to record 100 Hertz. But there's this tricky thing where a high frequency signal can appear as a lower frequency in digital sample data. It's a fake signal or an alias of that high frequency signal. So how do we get rid of that? Well, we need to use filters. I talked about filters last week and how they can introduce fake signals as well. So it's always a trade-off between what you can do to best replicate that original signal. To get rid of the alias frequencies, we first need to get rid of everything above that frequency that we're not interested in. That means making a filter that by the time it gets to 100 Hertz, there's nothing left. But filtering algorithms can't be too sharp. We need to ease those amplitudes out. So digital filters start to roll off the amplitude at about 80% of that target frequency. So that means we're only getting about 80% of that 100 Hertz nice and clearly. So to get that full 100 Hertz, we need to sample at 250 samples per second, which gives us 125 Hertz bandwidth, and 80% of that is 100 Hertz.